for the practice problems, let's start with number 22. Number 22 gives us that a sub 1 is equal to 5, and what else does it say? A sub k plus 1 is equal to negative 3 times a sub k. Alright, so what they want us to find is the first 5 terms and the common ratio, and then to write the formula. They want 3 things. So first, let's write the first 5 terms. The first term is easy. It's given. It's 5. Okay. So how do we find the next term? Well, somehow the secret must lie within this statement. Okay. And it's not too complicated. Say I'm going along in the sequence and I come upon a term. Say this term is a sub k plus 1. Well, what are the terms around a sub k plus 1? Well, the next term would be one more than a sub k plus 1, so it would be a sub k plus 2. The one before it would be a sub k. It would be one less than a sub k plus 1. You subtract 1 from this index. So a sub k is the one before a sub k plus 1. So what's this saying? It says for any term, if you want to get to that term, let's take negative 3 and multiply it by the term, what, before that term. So take that term, multiply it by negative 3, you're going to get to that term. So we'll take 5 and multiply it by negative 3, so negative 15. Multiply that by negative 3 and you get positive 45. Multiply that by negative 3, get negative 135. And multiply that by negative 3 and you'll get positive 405. Okay, and they would like us to tell them what is the common ratio. Okay, so this is like part A, though they don't call it part A, but we'll call it part A. So the second part of it, part B, is they want to find the common ratio. Well, that's pretty easy because we've been multiplying by negative 3 to get to each term, and that's the definition of the common ratio, so it's negative 3. R is equal to negative 3. So let's now, part C, the last part of this question is what's the formula, the rule for getting a sub n. So a sub n is equal to, remember what that formula is. It's a sub 1, just write it, a sub 1 times r to the n minus 1. So a sub n is equal to a sub 1, which is 5, times negative 3, that's the common ratio, to the n minus 1. And we're done. Okay. Let's go to 25. So in 25, a sub 1 is equal to 4, a sub 4 is equal to 1/2, and n is equal to 10. What do they want us to do? They want us to find the nth term, the 10th term here, of the geometric sequence. Okay, so how can we do that? Well, we want to find the 10th term. We want to find a sub 10. That's going to be equal to the first term, a sub 1, times the common ratio to the n minus 1 to the 9th. Okay, so that's a good start. A sub 1 we know, a sub 10 is equal to 4 times the common ratio to the 9th. What's the common ratio? That's what we need to find out. Well, we could do this a couple different ways. We could look at it this way. Here's 4, and that's a sub 1. So here's a sub 2, I don't know it. Here's a sub 3, I don't know that. I do know a sub 4, it's 1/2. Okay, how do I get from 4 to 1/2? Well, I multiply by the common ratio each step of the way. Multiply by the common ratio, multiply by the common ratio, multiply by the common ratio. So you multiply by r, multiply by r, multiply by r. If I multiply by r and then multiply that by r, multiply that by r, that's r to the third. Not 3r, I'm not adding r's, I'm multiplying by r, so r to the third. So 4 times r to the third is equal to 1/2. Oh, so now I'm going to solve for r. I'm going to divide by 4 on both sides, so r to the third is equal to 1/8. Take the cubed root of both sides, and r is equal to 1/2. Okay, so we found r. So a sub 10 is equal to, well, let's just plug r in there, I guess. The r is 1/2. Okay, So the 10th term is going to be 4 times 1/2 to the 9th. Don't know 1/2 to the 9th off the top of my head. Let's take 2 to the 9th. 5, 12. So we have 1 over 128 if you do all this math here. 1/2 to the 9th is 1 over 512, and 4 over 512 is the same as 1 over 128. Okay. Now I said you could do this a different way. It's going to yield the same results, but you can think of it as using the formula, right? That remember, a sub n is equal to a sub 1 times r to the n minus 1. So we know this a sub n, this is a sub 4. A sub 4 is 1/2, is equal to a sub 1, that's 4, times r, I don't know what that is yet, to the n minus 1. What's n? This is a sub 4, so n is 4. So n is 4, 4 minus 1 is 3. Same result, but thinking about it in two different ways. Thinking about it as in terms of using like the formula, and here thinking about it in terms of kind of a picture and just the concept. As time goes on, if they give you a big gap between a sub 1 and maybe a sub 35, you're probably not going to want to draw this picture. You might want to use this formula, right? But this also kind of brings the formula back into, conceptually it makes sense. All right? All right, so that's 25. Let's do 30. A sub 1 equals 1,000. R equals 1.005, and n equals 11. They want us to find the 11th term here. Okay, they want us to find a sub 11. Let's see how much of this equation we have. This is going to be a sub 1, that's 1,000, times r, that's 1.005, to the n minus 1, that's 10. Well, there wasn't much to that problem, was there? And probably this isn't going to be a very nice number. We might want to just leave it the way it looks. Let's see what happens to the 10th. Yeah, that's not so nice. Like, we could leave it like that, or we could say it's about 1051.14. Okay? So, make sure I put that on right. Yeah. So this would be all right too. Good. That's number 30. Let's do let's just conserve paper here and do number 36 on this side. So we want to, just checking my time there. I'm going to find the formula for the nth term of the geometric sequence and find the indicated nth term of the geometric sequence. Okay, so we want to find the formula, and then we want to find the term that they want us to find. Okay, so here's the pertinent information about the sequence for 8 and 16. And then it goes on from there. They're telling us a geometric sequence, so we can with that assumption, we can find out a lot about the sequence. What they want us to find is a sub 22, the 22nd term. All right. Well, a sub 22, that's equal to a sub 1, that's 4, times r. Well, I don't know what r is. Let's find out what r is. To find r, I just take one of the terms and divide it by the term before. 8 divided by 4 is 2. And we can check it. 16 divided by 8 is also 2. Okay, so 2 to the n minus 1, it's just 21. So a sub 22, I don't know why I went way over here. Maybe I'll take up some space and say that r is equal to 2. So 2 to the 21st times 4 is huge. A lot of 8's in there, so 8,388,608 is a sub 22, the 22nd term. Alright, let's see, number 48. 48 says the sum of the first six terms, using this rule. Okay, so remember, we have a formula for this. The nth partial sum of a geometric sequence is equal to the first term in the sequence times 1 minus r, the common ratio, to the power of n, the n of, the number of terms you're trying to add up, over 1 minus r. So this one here is going to be the first term, so we're going to find the first term. We're going to plug 1 in here. That's the first part of this equation. So plug a 1 in here, 1 minus 1, that's 0. Okay, so that's 1/4 to the 0. That's 1. Anything to the 0 is 1. So the first term is just 32. So this is going to be 32 is the first term, times, we got this fraction here, 1 minus r to the n. Okay, 1 minus r, which is clearly 1/4, to the n. N is 6. And it's over 1 minus r, which is 1/4. Alright? So we may as well just go ahead and do this all in the old TI-83. 1/4 to the 6th, and then we divide this by 3/4, or 0.75, and we should get about 42.656.